Welcome back everybody to Rikers Island ICND1 course. In this video, we're going to be taking a look at comparing and contrasting collapsed core versus three-tier architectures. Well, it won't be just versus, it'll be and. When it comes to these two different types of designs, there's a couple of things that really need to be understood when it comes down to why you would go one over the other. So, if you're not familiar with the idea of collapsed core or three-tier architecture, I'm going to go ahead and dive right into a setup that I've got going on here, and just more diagram than anything else, just to help put it into perspective for you. So, let me go ahead and pull out and grab the pencil here and make this a little bit thicker so that I be able to whiteboard as we go here, folks. So, you have the single layer design, right? The single layer design is an indication here that we have a single layer where our computers connect directly into a device of some type. This could be a layer 3 switch. It could be a router with a ether switch module in it. What it's actually connecting to is really arbitrary. This could be a firewall. This is typically firewall services here. This is layer 3 and this is layer 2. So basically that's how you would associate these layers right here. Now one of the things you'll notice right here is we have this little line that's drawn is a little bit longer than these other arrows pointing outward. It's coming down into the switching module down here. That is an indication of inter-VLAN routing. So this guy right here could be in VLAN 10, this guy could be in VLAN 20, and they'll be able to talk to each other because you'll have some sort of layer 3 functionality allowing the redistribution or the inter-routing of VLAN information between the two networks. So that's just a general level set on how that comes into play. Now, in very small environments, for most cases, if you are at the ICND1 level, you're going to be more or less focusing on that. You might be in charge of a branch network or supporting a branch network. Small network, a few devices, nothing super complicated. Now, one of the things that's interesting about ICND1 is based off of the certification. I never use the certification to base the experience because that's not a good tie of certification to experience. It really isn't. So that's just normally where, if you're brand new to the industry and you get certified, that's typically where you're going to start. Now, if you're like me and you've got 5, 6, 7 years of experience, and I go get ICND1, you can't map the two. I'm going to know a lot more than an ICND1 engineer. So then it's a little bit different. Like I said, certification does not dictate experience. So if you are articulate, then you should be in good shape. But this right here is an indication of how this kind of a design would come into play. So you could consider this to be, SMB, small to medium-sized business customer. You have a single site or maybe a couple little sites. You don't need to have anything robust. You could literally have one device as your central point of management. Although I don't believe in a single point of failure scenarios. Actually, let me go bump this down just a little bit. I'm zoomed in a little bit tighter than I thought I was. Single point of failure. And all that means is if the power or internet goes out, so does the network. That's really all that comes down to. Now, moving to the right a little bit here, we have a situation where we have collapsed core. Now, collapsed core in this particular situation refers to you have access layer, which means VLAN 20 and VLAN 10 are logically and physically separated from each other. In order for them to communicate with each other, they would have to go through a common aggregation point. This could be your aggregation. Now, let's focus on something that I know someone's going to ask because you probably don't know any better, which is okay, but I'm going to point it out. Well, why don't you just run a cable from here to here? Well, we haven't covered spanning tree yet. This would cause a loop. So this port or this port would get blocked. Well, why would it get blocked? Well, the problem with Ethernet is it's a flood and learn style environment, technology, which means if this guy advertises himself as a network, he's going to learn, we'll say this is port 1, and this guy has MAC address A. Port 1 is going to learn A, and let's say that this is 3, this is B, and this guy here's port 3. So then we're going to have 3B. Okay, and then we have this guy here is going to be, we're going to say is, F, and it's going to be, 10. So we're going to say 10F. Well, I know all these ports. On port 1 I learned MAC A, on port 3 I learned MAC B, on port 10 I learned MAC F. Well, the problem you're going to get is you're going to be able to send information out both ways. And then this guy will receive it, and then he'll be able to send it both ways. And then this guy will learn it, and he'll learn it in and be able to send it back out both ways. That's why it's a bad thing. So your best bet is to not do this. Do not put a cable between these two switches unless these are layer 3 links. Let me draw layer 3 a little bit better. Now this is layer 3 and this is layer 3, which is totally possible. Then a bridge between the two, layer 2, okay. Why? Because you're only going to be communicating in between these two switches. So it's okay to have VLAN spanning switches, but the moment you have two cables running, one of these ports is going to be down unless you port channel them together to make them look like one. I'm getting way ahead of myself. This is CCNA level stuff, but it's important to understand why you would versus why you wouldn't do that. So I would say if you're going to be doing this, a single cable between them is just fine. If you need to get connectivity, however, in this design here, we are layer 2 from here down. This is layer 2, this is layer 2, this is layer 3. So that's going to be a key indication here. So we're routing in between the access layer switches to get VLAN 20 to be able to talk to VLAN 10. And that is a very big deal. This is what they call collapsed core. Now, you could also take a look at it from this collapsed core over here. This collapsed core is a router that, and you've got collapsed layer, core layer, and then we have the collapsed distribution. Now, typically speaking, if I have a collapsed core, this guy would be VLAN 20, this would be VLAN 10, and this guy here is the default gateway, and this guy is a default gateway, and then these connections up here are layer 3, and this one here is layer 3. And then from here it goes up. This could be, let's say you've got another platform up here that you're utilizing. Maybe what you're actually doing up here is you have a 6500 and you've got a very, very beefy switch that can do routing functionality, and he's doing layer 3 up this direction. That could also be the case. Normally, I would not do this. Now, mind you, you notice at the top here there is some brickwork or brick. It looks like it's brick up here, which could be firewall. The 6509 has the firewall switch module, which does allow you to plug in an ASA module into the 6500 and be able to do firewall functionality. Not recommended, but it can be done. So this is another variation of collapsed core. Collapsed distribution is a little less common than the collapsed core, collapsed distribution of this guy over here. I would say this one right here is more common than this one, not as common, but it is still out there. Now, to take this to the next level, we have this guy right here. This guy right here is an example of a core distribution access. Now, we've covered the material up to this point, but I haven't talked about this yet, and it's actually slipped my mind until I just thought about it. Why would you want to do this? And I'm actually going to be hitting that here in this one here in just a moment, but I wanted to make sure that I hit this as I was going along. So what you're basically doing is, and I haven't talked about broadcast domains, I haven't talked about collision domains, I haven't talked about subnetting or anything like that yet, which is part of the reason why I haven't hit it yet. But one of the really, really, really big deals that you really need to understand, and it's really important, I'm going to stop saying really, when you're dealing with this stuff, having a way to break layer 2 boundaries is a good thing. What do I mean by a layer 2 boundary? Well, typically speaking, your access layer switches are going to be running at layer 2. This guy's going to be running at layer 2. Up here, we're going to be doing a layer 3, layer 2 boundary. Layer 2, layer 2, layer 3, layer 3, and then from here it's going to be layer 3 up to the core routing. There might be another layer in between here, but normally this is going to be a very common design. I almost always go with this type of design. This is my preferred. Why do I say that? Because of the fact that it scales really, really well. And I can sit there and take an extra core distribution layer switch, plug it in, and run some connections and be good to go. I could scale out my access layer and grow it out as I need to. There are situations where you don't have the router connections that you need. That's completely okay. Normally what I would do is I would put a box in between here. And this box would connect my routing, my WAN and my internet edge to the rest of the network through some sort of multiplexer. Multiplexer being just another switch. I would take a switch that would connect me. I would call this my WAN switch. The reason I would call my WAN switch is because of the fact that it would be a way for the 2 to 3 connections from here and the 2 to 3 connections from here to plug into this switch, and then be able to plug into 2 by each distribution switch, and I could scale that out as wide as I go. As long as I have ports available up here in my port bank, I should be good to go. Whether this is a stack or something else really depends on the situation. But I could sit there and take something like this, and then I could start adding in, if I needed to add another distribution switch in here, and then run more cables down to here, I could do so. It really depends on the situation at hand. So I could scale it out as wide as I want, which gives me that flexibility of saying, okay, you know what? All is well, I can scale out. That's one of the things that you'll find about most networks that you walk in, that the network is designed typically to meet the current day, the current need. Most engineers that I've worked with don't think ahead, a year or 2 or 3 or 4. I'm actually in the process of redesigning a very large Fortune 500 network right now. It's a big retailer here in the Milwaukee area, and I'm in the process of redesigning their LAN and WAN edge. Multi-million-dollar project. It's taken me a few months already to even sit down and vet out providers that'll be able to give us the capabilities that we need and things like that. We're totally redesigning the network. We're moving boxes around. We're buying new equipment. The build of material, or BOM as we like to call it, continues to grow. I'm looking at, one of the things you'll find is a good design won't be just one Visio or one diagram. It'll be several diagrams with multiple solutions at varying cost levels, at varying complexity levels. You might have one that says, okay, you know what? I've worked on this design and if I had all the money in the world, the money was not a problem, this is the design I would go with. Okay, and the design is going to cost you $2.4 million. I can have it deployed in 6 months. You could also come up with another design that would say, you know what? Let's assume I can't get the 2.4 million I need, but I can get the 1.3 million that I need to get some base functionality to work. Here's how this design would roll out. If I can't get my main way of doing things, I have a secondary route to go. Let's say you do another one. You do option number 3, which gives you it's $300,000 to get everything rolled out, and it's a stepping stone. You give me the extra money for whatever's I didn't have available in Project B, which is that 800,000. You can roll that in 6 months, and then I'll be able to migrate all this over to option B. And then 6 more months after that, when the money comes available, I'll be able to do option A. So being able to produce a stepped solution provider, then you'll be able to articulate to your leadership that you understand what the network needs, and you know how to scale it in a manner that won't be impacting on the network. That's one of the things that I'm working on right now, and it's a lot of work. I mean, it's not something that you can just walk into a whiteboard session 10 minutes later and bang it out. It takes a lot of thought, takes a lot of time, a lot of discussion, breaking things down, understanding what's where are we at, how much money do we have to spend, things like that. And being able to present my manager with several solutions, because the more, just like I mentioned in a previous video, if when you're trying to either deploy a new scenario or deploy a scenario or solution for a business scenario you've been presented with, whether you're trying to troubleshoot a problem and you're trying to gather factual information to troubleshoot the problem and find the issue and resolve it, or you're trying to design a new network to take the current network to the next level, the more ammunition you have to work with, whether you're handing off that ammunition to a manager who's going to go to his boss and say, you know what, here's what we need and this is why we need it, and give them multiple angles and say, okay, you know what, here's everything I've got. Give him everything you've got, and then he can make the decision as to which way we go. Say, okay, you know what, this is what we have, this is what we have, this is what we have. This will get us where we want to be in this amount of time it'll take us to get it in. And then if you give interim steps, your projects will take off a lot faster. If the money's there, the projects will go. If the money's not there, obviously the projects may stall. It may take a while for the money to come through. But that's one of the things where understanding the architecture. Then you might say, well, why am I going off on a tangent? I'm really not. I'm explaining when it comes to architecture-wise how to give you an idea of how to take that into consideration, because you may not be in a WAN design, you might not be redesigning the WAN, but it might be you as the engineer may look at the network and say, you know what, this needs a lot of work. But there's no plans at all to redesign the WAN because maybe a year ago it was just put into play. Everybody's happy. They're kind of they're in a valley right now, and they want to keep everything running smooth, all is well. They're kind of in, autopilot. I personally, if you know who I am or you get to know me at all, I don't like autopilot. Autopilot, I get bored. So taking a look at the network and going, okay, this is what's going on, even if you don't necessarily need the bandwidth, but you need its potential down the road, you want to scale it out, that is where your value becomes there. Because then you can say, you know what, I've done this, I've done this, I've done that. If you do this on your own and you come up with this design and sell it to your manager and your manager likes it and he goes and sells it to his boss, and then all of a sudden money starts rolling in, it gets stuff done. Obviously, perfect world, perfect scenario, but that gives you that leverage. You know what I mean? It's one of those things that comes into play that you have to understand what you're looking at, and that's going to equate to, okay, you know what? You weren't told to do this. You took it upon yourself because you want to make sure that the network is highly available and resilient. And that's a big deal for a lot of employers. So you have that design. Now the next one we're going to take a look at is a little bit different. This one is very, it's kind of unique. And this one here, you can ignore the multicast terms down there. But you might ask, well, how come we're looking at, how come you want the separation? Why is the core distribution access so important? Well, the reason why is, you'll hear this term called VLAN block. Basically, the VLAN block is a way for you to cordon off or logically segregate. So let's say, for instance, we have one VLAN block here, you have another one right here, and you have another one right here. What this does is, as long as the distribution core and that topology right there is the layer 3 gateway for all of those networks, then if let's say access 1 here, this guy right here, if one decides to check out and not come back to work after lunch, well, you don't lose connectivity to the rest of the network. The rest of the network stays operational. Your access 2 and your firewall stay up and running, right? That's the key factor here. It's how do I mitigate network issues by separating broadcast domains. Now, if you have one flat layer 2 network, yes, that will work. Yes, you can have different subnets. Yes, you can have multiple services running. However, if one thing happens in that network, everything falls. It's just the nature of the beast when you do that. That is why large flat layer 2 networks are a thing of the past. back in the 80s and 90s when that was popular, yeah, it was popular, and then people got smart and decided not to do that because the stuff would break. Spanning tree protocol is a great thing if you know how to use it. And I will show you the principles to understand it, but it's really, really important that you understand that flat layer 2 networks are a bad design every day of the week. So if you have the ability to go in there and say, you know what, I need to focus on making sure that my access layer, especially for mission critical devices like the server farm, are logically segregated in their own subnet, own VLAN from the rest of the network. So that if all this stuff right here decides to stop working, this guy will be A-OK. Why will it be A-OK? Because it's logically not the same network. That's why. Because then I can sit there and go, okay, you know what? The server farm has data going on inside of it, and let's say, and the reason I bring this up is because just recently, the company I work with, we had a layer 2 loop in the network. Somebody plugged in a device into the network, and it took down a good portion of one of our larger corporate sites. Well, it was mad dash to try to get it back up and running and figure out where it happened and how it happened. Well, it's unfortunate that it happened, but after it did happen, we started looking at some things and noticed why we were having problems. So it was just a matter of me going through and saying, okay, well, here's a problem, here's a problem, here's a problem. So being able to separate that, and because of the fact that we had things broken down into VLAN blocks, like we do, we were able to mitigate the issue only to a certain building and a certain floor. Just a couple of, like, what was it? I think 57 people were affected, which basically is two 3750 stacks. We were able to mitigate the issue down to just that little area of people because somebody plugged in a switch into a conference room wall jack, and it caused a layer 2 loop. Problem was easily remedied, but we had to find out where the problem existed. And that's one of the reasons why it's important to understand how these components come together. My last and final aspect will be a scaled out approach to how the network would operate. So in this design here, you have 3 separate broadcast domains. You've got 1, 2, and 3. And the key factor here with the distribution is supposed to keep the other aspects of the network from failing. So if distribution 1, 2, or 3 has a problem, then it's not going to affect distribution 2 and access 2, or distribution 1 and access 1. It's only going to affect distribution 3 and access 3. Now, because of the fact that each one of these connections you have core 1 and you have core 2, this gives me that flexibility. Now, I could have core 1 and core 2 connecting to my WAN cloud here. That's a potential solution. I could have it connecting to my internet, and then it connects this way. That's another potential solution. The core is typically going to be where you are going to be determining where stuff goes. So the access layer handles end users, printers, access points, etc. Distribution is going to take the aggregate of all of the access and bridge and bundle them together and send them up to the core, which is what's happening here. The distribution switches here are taking that data and sending it up to the core. The core then makes the decision, do I go to the internet or do I go to MPLS? Do I go to the WAN, whether it be frame relay, ATM, MPLS, doesn't really make a difference. And then I can sit there and go, okay, from here, where do I go? Then if it's got to go over to the WAN, it goes to the WAN. If it goes to the routing, and then based off of the routing table in the core, will determine that. Where am I learning that route from? And you'll see this when we get into the routing aspect, when we start running RIP and take a look at static routes. That'll be an indication of what's going on. So those are some components and pieces that are really important for you to understand, and that's why I drew it out the way that I did. I wanted to get a couple of easy to follow diagrams that would put that into play. So like I said, if access 1 and distribution 1 are having a problem, then distribution 2 and 3 and access 2 and 3 are not having a problem because they are logically separated. As long as all these links from here down are layer 2 from here, so everything below this line will be layer 2. Everything up in here will be layer 3. This will be all layer 3. And that's how it should be. If you've got layer 2, you're still going to get flooding in play. If you're layer 3, your flooding will terminate at any layer 3 boundary. So your default gateway will be the limit to how far you can flood. So if I'm hitting the distribution 1 for my layer 3 routing, then that means that's where my broadcasting will stop. I can't flood beyond a layer 3 domain. There are actually some situations where you could do that, but for sake of argument, there is no way to do that. Now, one of the things that's actually kind of cool, and it's out of scope for now, but I'm going to bring it up anyway, is the concept of not having to do this, right? Well, you may have heard this term, and if you have, great. If not, no big deal. VXLAN. Now, VXLAN actually would fit very, very well, and this is the reason why I'm bringing it up. And this is actually one of the solutions that I am pushing to deploy in my corporate network. Actually, in several networks at the moment. The idea here is distribution 1, 2, and 3 all can reach each other via IP, right? So regardless of the IP address that you have configured, they're all reachable. Distribution 1 can ping distribution 3, and the traffic has to flow through core 1 and core 2 to get there, right? Well, that would work out. This also could be an ACI type of rollout to where you have your spine and you have your leafs. So an ACI core is going to look like that. Well, you could have, say, a Nexus 5600 here, here, and here, and you could connect all of those devices together via VXLAN. And then the termination point of the network would be at your distribution layer, which is also your default gateway. So if you have access PC2 here, one's talking to access 2 PC2, if these two want to talk to each other, then this guy would send the data up to here to the switch, this guy would go up here, and then it would be VXLAN encapsulated to here, and then drop back down. VXLAN is just encapsulation, just like your .1Q trunking, and your MPLS, and your frame relay, and all that type of stuff. Just encapsulation at the end of the day. There's nothing fancy about it. So you could do that. That's a situation that does come into play very, very commonly. But because of the fact that most networks are looking like this, where you have a spine leaf topology, this is a very good design to roll out VXLAN in. If this is how your network is laid out, and you have Nexus as a layer 3 edge, and they support VXLAN, I would strongly recommend you have a look at that as a potential solution, because it does help eliminate a lot of the flooding. Because what will end up happening is, from here up, the rest of the network doesn't need to know about any of the MAC addresses down here at the access. Because the fact that this is the layer 3 termination point, only the other distribution switches would have to know how to get to each other. That's the idea behind VXLAN. You're hiding the network from itself. This also implies that you have a very high-speed, robust network for your underlay, and go from there. Where this would be your underlay, all the physical connections. This is underlay. This is VXLAN is an overlay. Not to be confused with overlay transport virtualization. It does a similar operation, except for OTV is proprietary to Cisco. VXLAN is open source, which is why I like it. It can be used. I've tested it out in a service provider environment as a managed CE to managed CE connection, where I need to bridge layer 2 over layer 3. It can be used for migrating a VM from one data center to the other, cross vCenter, vMotion, things like that. If you don't know any of these terms, that's okay. I'm going to be hitting them as we go along to put some real-world use cases together so you'll understand what it is we're talking about. For the most part, this stuff really isn't that complicated. It's more important for you to understand why the design is the way it is and how it comes into play. If you understand that piece, which I'm sure you guys are picking up what I'm putting down, you'll be in really good shape. Beyond that, that is pretty much the reason why you would want to have the network the way you would want it. Now, if we take a look at our topology here in Packet Tracer, you're going to see that my topology is very similar. I have a switch connected to 2 upstream switches. This is actually a collapsed core, and I did this on purpose because I didn't want to have an abundance of switches that I didn't need to have an abundance of switches for, if that makes sense. So that gives me that flexibility of coming in here and playing around with stuff. So as we go forward, we get into the layer 3 routing piece. You'll be able to take a look at how this actually breaks down. We haven't gotten to routing yet, so I don't see the need to put it out there yet. But I'll add in IP addressing and subnetting here in an upcoming video, and then you guys can take a look at exactly how that'll come into play. So I hope this was informative for you guys and that you learned something new from this video. Until next time, guys, please take it easy.